Okay, so I think we're going to go ahead and get started. So I see Alex trying to walk away, but we're going to bring him right back up here to talk a little bit more about, we've heard a lot about what we've done and where we've come from, and now Alex is going to share with us where we're going. So.
Thanks, Aurora, and last piece of Alex for the day, I guess. So yeah, for this session, I wanted to have various speakers come and discuss about some of the things that are on the horizon for us. Briefly, we have Charlene Son Rigby. Did I say that right? Chief Executive Officer at Rarex. We have Shlok Rohatagi. Shlok is the summer intern of RDCA-DAP. He came 2 summers in a row, so I guess he likes us. Pam Gavin is going to come back at the end of the session. Ramona Walls. Ramona is really essential to the development of the platform. She's executive director of data science for our data collaboration center, and she's an ontology specialist, and she really drives a lot of work in terms of technological development for the platform. Penny Dacks is going to join us at the end for a Q&A. Penny works for the Association for Frontotemporal Degeneration, and she is also president of the AFTD Disorders Registry. So first, I wanted to just give a brief introduction on how we're seeing RDCA-DAP moving forward, and really we're pushing RDCA-DAP now as a real collaboratory. So what is a collaboratory? I like a good Wikipedia definition. From the first definition I think that I've seen really fits well from William Wolff in 1989. Collaboratory is a center without walls in which a nation's researchers can perform their research without regard to physical location, interacting with coding, accessing instrumentation, sharing data and computational resources, and accessing information and digital libraries. So, with some wiggle room around the definition and maybe us wanting to do a little more than that, I think it really fits what we're trying to achieve with RDCA-DAP, being a trusted collaboratory for the entire rare disease ecosystem, working with all the organizations in the space, foundation, industry, registries, and other rare disease data platforms, working with all types of data, working for all rare disease without limitations, and advancing new tools to accelerate drug development in rare disease, and also a reactive entity that is going to evolve with the rare disease ecosystem, and really adapt as the space evolves and as the technology advances, really be reactive. Internally, I'm going to be brief because Hong really talked about that. We're really trying to, as a collaboratory, to be the glue to all the rare disease activities that are ongoing at C-Path. That means working internally to help facilitate and collaborate with the other rare disease public-private partnership that we have at C-Path. And as we go along, opportunities for collaborations are arising, and we're having some engaging discussions with the COA consortium, with Terina, D-Risk. We really are hoping that we'll create opportunities for joint collaborations on scientific projects in the future. But also, part of the thing that we do is expanding the data, leveraging the database of the RDCA-DAP, really digging into the data and start leveraging this database to develop insights on new rare disease. So we have some work groups that are being developed, and we're really trying to push them forward. We are also going to facilitate the more recent public-private partnership efforts, such as the pre-consortium that Hong talked about. Externally, we really want to collaborate with the entire ecosystem. Really, the idea is that we want to be a partner, not a competitor. So collaborating with other people that collect data or work on rare disease data, it's going to help us really break the sharing silos that can happen across the entire ecosystem. That's going to help us increase the data content of the RDCA-DAP database and also increase the prowess of the RDCA-DAP. And hopefully that's going to create opportunities for collaborative solutions with external partners so that we can accelerate the development of solutions for rare disease. Some examples of these partnerships or collaborations, the strong collaboration with NORD and the IAM Rare Registry. We talked about it. We have complete federated access with the NORD IAM Rare to increase the registry data content that we have in the platform, with a facilitation of updating of data, and really a work that NORD is doing to streamline and improve the flow of registry data to RDCA-DAP. And some opportunities for RDCA-DAP IAM Rare solutions are on the horizon as well. And I think Pam is going to touch on that during a presentation. We have some opportunities that are on the horizon, and some plans with Elisa to start developing analytical solutions together. Another example is a collaboration with Vivli. It's a clinical trial platform data with a lot of trial data from industry, and the idea would be to integrate Vivli clinical trial data into RDCA-DAP. It is still ongoing. We're awaiting some decisions, but I'm very hopeful that it's going to pan out and we're going to be able to access more trial data through that collaboration. And finally, Rarex, we're very early, but we're discussing a collaboration so that we can work together to aggregate some of Rarex registry data with selected data sets from RDCA-DAP, with some early exploration on maybe aggregating data in the space of neurological disorders with seizure. So with that said, I'm going to leave the room to Charlene.
Hi, everyone. I'm Charlene Son Rigby, and I'm the CEO of Rarex. Thank you for inviting me today. It's been a really exciting meeting, and talking about data plus advocacy is one of my passions. So I'm excited to talk with you today about how we're starting to work with RDCA-DAP to address data challenges in the rare space. Just as a personal background, so I've spent my career building software solutions for analyzing big data, mainly in the healthcare space. And I've actually spent the last decade building AI-driven analytical approaches to interrelating genomic and phenotypic data to accelerate rare disease diagnostics. And I'm also the mom to a 9-year-old girl who has a rare neurodevelopmental disorder called STXBP1. And so I really come here with a combined tech and advocacy background. And now I see what you mean about the blinding light. Don't know why I didn't notice that before. All right, so I'm going to start my talk with this slide. And what I really want to do is frame how we're thinking about this collaboration between Rarex and RDCA-DAP. And I think that there's really great complementarity between what our organizations are doing respectively. Rarex is driving novel data collection of patient-reported outcomes, and we're doing this in a way that generates patient-owned data. And RDCA-DAP, as we've been talking about today, is aggregating broad and disparate data sets and actively working on solution development to accelerate data analysis. Our shared values include what you can see at the bottom here. So really facilitating the broadest research access and responsible use of data, promoting interoperability and data standardization, and generating more insights to power solution development. So now what I'd like to do is introduce Rarex. We are a nonprofit health technology organization, and we are also a patient advocacy organization. This core focus, this dual core focus, is really important to Rarex. We have built a technology platform and a research program to collect robust patient-reported data. And we've deployed an open science platform that supports and enables collaborative data sharing to accelerate understanding of disease as well as therapeutic development. Importantly, we've also deployed a key capability, which is a full service patient engagement team to drive successful enrollment and ongoing engagement with participants. So Rarex was started to address several key challenges, and I think I don't even need to talk about what they are today because I feel like I'm preaching to the choir. So the first is data silos, and I know we've spent a lot of time talking about that challenge today. The second is the lack of usable data, and so some of this is that data has not necessarily always been collected utilizing data standards, which can create challenges for downstream analysis. And the other piece is around really utilizing robust methods and COAs to collect that data, which was a point of discussion before the break. And finally, one of the biggest challenges that we have in rare disease is that data often doesn't exist. And, it's often the rare disease patients, the advocates, who are really working to kickstart research for their condition, which I think Ed and Eliza covered, as a challenge in the last talk. And it's often difficult to generate researcher interest if you don't have any data to start with to get them excited about, not to mention the fact that it's expensive to start collecting data. And a final and important challenge is that patients are not empowered to make decisions on what's happening to the data that they're contributing. So Rarex has deployed a research program and a technology platform to address these challenges. And one of the things I wanted to point out is given the expense, what we've really tried to do is make it a core aspect of the program that the standard data collection within Rarex is at no cost to advocacy groups. Another key aspect of our program is data governance. So we manage an umbrella IRB. So we deburden patients from having to manage an IRB directly. And our governance includes a broad consent, as well as a novel data sharing preferences agreement, which is separate from the consent. And it enables patients to determine how their data is going to be shared and to be able to actually update that over time. We're also investing significantly in data standardization. So with early characterization of disorders, and even in situations where conditions have been characterized, we don't necessarily know the symptoms that any individual rare disease patient may have because of the heterogeneity of many rare diseases. So what we do is we start here in the center in this red general core with a head-to-toe survey, and then we expand out to deeper data collection depending on the participant's symptoms. Importantly, this approach enables us to collect robust data across disorders. And all of this data collection is mapped to data standards, including HPO and OMIM, which facilitates downstream analysis and data federation. We want to use existing measures to collect data where available, and we convene expert working groups to guide our work. So here's an example from pediatric neurodevelopmental disorders. Our working groups are comprised of clinicians, researchers, as well as patient advocacy leaders. And they start by prioritizing the top domains, the top symptom domains. And then our team landscapes and characterizes existing patient-reported outcomes. And in this work group, for pediatric neurodevelopmental disorders, there were 252 measures that were identified across the top 10 symptom domains. And then the work group narrowed down that 252 to 50 promising measures, and then finalized this down to 13 measures that are being implemented on the Rarex platform. So here's a snapshot of the patient communities that are currently collecting data on Rarex. We launched the platform in Q3 of 2021 and now have over 40 patient communities. And there are a large number of rare neurodevelopmental epilepsies represented. So I'm excited about the potential for federating the Rarex data with the Rare Epilepsy Network data that Shlok is going to talk about in, hopefully, the next talk. Rarex's work supports a growing partner ecosystem that includes patient advocates and advocacy groups, as well as researchers and biopharma. And we really are supporting research all the way from early characterization of a disease to generation of baseline data and disease progression data. And here are some of the types of studies that we can support. I want to show one use case here as an example. We're supporting a new neurogenetics clinic at Colorado Children's, and this program is supporting multiple rare neurodevelopmental disorders. We're collecting multiple clinical outcome assessments, so the standard data collection on the Rarex platform, as well as clinician reported data, and several additional disease-specific PROs. This structure provides a basket-style natural history study across multiple disorders, and it's also a scalable model for data collection that helps us to deburden clinicians as well as participants. So I'm going to wrap up with an architectural diagram. So Rarex is enabling rare disease patients to collect, structure, and share patient-level data. We're investing deeply in mapping to ontologies and data standards, and significantly in curation of this data. We're also aligning it with partner data, such as electronic record data that's been curated by Citizen. And now we're looking forward to advancing our collaboration with RDCA-DAP to federate data with the goal of accelerating rare disease research and benefiting patients. Thank you.
Thank you, Charlene. So before our next speakers, I just wanted to touch briefly on the RDCA-DAP database, and I was just asked the question by someone in the audience. So currently we have more than 25 different rare diseases with at least one data set. I just really want to insist, this is a snapshot of mainly RDCA-DAP driven data acquisition. There is way more in the pipeline. And there is more at C-Path in rare disease, in terms of rare disease data. So keep with us as we go along. More data is going to be curated, made visible throughout the platform, and potentially accessible. So I'm not going to go through all of that. I just wanted to point out to make the transition between Charlene's discussions and Shlok's presentation. Recently, we've seen a lot of acquisition of data in the space of globally neurological disorder with seizure, or I would say rare epilepsies, with data coming in from registries, foundations, but also clinical trial data that has been shared to us very recently, with a lot of ongoing conversation. So there is a small but significant momentum in that space with some opportunities, and we started to leverage this data. And Megan and Shlok have been working throughout the summer on early exploration. So Shlok is going to come in and showcase you some of the early cross comparison you can make between two different data sets, two different registry data sets in rare epilepsies. Really showed you what hands-on things you can do on the platform. And then Ramona Walls is going to come in and take it one step further to try to tease you what is going to be the power of the future technologies that is being implemented and what impact it's going to have in terms of technological advancement and also analytical solutions that we'll be able to make in the future. So please welcome Shlok.
Thank you, Alex. So as he already introduced, I'm Shlok, and I've been working for C-Path the last 2 summers. I'm extremely stressed to be here, but it is what it is. So I currently go to Rutgers University. I just entered my first professional year. So I have a long journey ahead of me, and by the end of it, I'll be getting my PharmD. Enough about me. Let's get started. So what are we looking at here? We're looking at basically two patient registry data sets that are currently on the platform. The two data sets are CAND and REN. CAND stands for the KIF1A associated neurological disorders, and REN is the Rare Epilepsies Network. We're going to be looking at the inbuilt data analytics tools, along with basically how to standardize that data and what the inbuilt data analytics tools can do without standardization. We'll also be looking at multiple other use cases. So what is REN and what is CAN? What does it include? Well, the REN dataset basically has about 1,455 patients, and it contains information on 40 different rare epilepsies, or sorry, more than 40 rare epilepsies. It also is all patient reported data. That means that one patient could write 3 months, another one could write 1 year. And when it comes up into our data sets, they're just written in one box, which requires a lot of standardization and manipulation in order to come up with good data representation. Now, this data contains patient development, it contains demographic data, it contains seizure. For example, when did the patient have their first seizure, their last seizure, how long they've had the seizures for, and the frequency at which they've had their seizures. It also includes medication data. And the other data set is CAND. This is an autosomal genetic condition, autosomal dominant or recessive, and it basically contains approximately 145 patients. This is also patient reported, and it is also registry data. It has different bits of information, such as clumsiness data, along with, of course, seizure information, such as first, last, frequency. And you'll notice how there's both the seizure information on both of these data sets, and that'll become very relevant in the next few slides. There's also information about anxiety, depression, and other neural disorders. So this is basically showing you a map. If you look on the left of what is in each one of these studies, it has a little bit more detail, including exact endpoints and what endpoints are could be examined. And there are other relevant pieces of information, such as the age when the registry was done for the patients, the number of seizures they've had, the first and last seizure, as I stated earlier. And at the bottom, there's a little graph showing a glimpse of the platform. So before standardization, before I get into what all of these graphs and figures are, I'd like to discuss what standardization of data really is. Standardization of, or before standardization of data, is just the information that we've gathered from the data sets alone. There's no manipulation in terms of coding. There's nothing that requires any special training. It's just whatever data has been given, along with a few minutes of manipulation and clicking around within the Iridia platform. On your guys' left, I believe. Yeah, left. On your guys' left, you'll be able to see a frequency chart showing age on the bottom compared to the frequency. And this is basically showing how, at what age were our patients having their first seizures. So if you count, I know the bars are really small, but if you look at the third one over there, at the age of around 3, we've had 120 patients that have had their first seizure, whereas at the age of 4, for example, there's about 150, which is also our peak value. And then on the right, there is the residual data, basically showing the correlation between the two. And now the before standardization for CAND. On the left, you'll be able to see basically a heat map showing the exact same information as in the previous one, showing the age versus the age of first seizure. And also this is relevant information because later on we're going to be looking at, when we combine these two data sets, what new values or new insights can arise. One important note to realize is that none of the KIF1A patients showed up in the REN trials, which means these data sets are completely independent. Right below the heat map, I know it's a little bit tricky to see, you have a bunch of information, bunch of numbers, basically representing the lines of best fit, the interquartile ranges, Q1, Q3, the median, mode, max. All of this really basic level statistical information that I was able to grab from the website within a few minutes using the inbuilt tools. And on the right, once again, this is all based off of the same two endpoints, is just showing the correlation of the two values. So now let's explore the standardized REN database. So what does standardization mean? Standardization is basically, now you might need a little bit of a special skill set. You might have to code a little bit. I know some people are, sweating already hearing the code. Trust me, I felt the same way. But it isn't as bad as you think it is. And with enough data wrangling, we end up with something like this. Megan helped me a lot with this one. So basically, we can just analyze and look at some things that are up here. For example, the scale is from 0 to 100%, and that's relevant looking at, for example, valproic acid. And that basically is one of the active ingredient drugs that was used for some of the people that had Dravet. But you'll notice that it's not even in one of the top 5 medications when looking at KCNQ2 compared to TS, which is right below it, which is at 51%, compared to any other rare epilepsy that only had 30%. So these are just some things that you can pull up to show for figures or do analysis just by looking at these graphs. Now the core morbidities in rare epilepsies. So over on the bottom, you'll be able to see the diagnoses ranging from anxiety all the way up to OCD. And just by looking at the data itself, it's hard to tell, okay, who has what's going on. But of course, using the platform and wrangling the data, and now combining these two different data sets, you can start to compare the two values and try to see what are the differences. And one of the ones that stick out very quickly is cerebral palsy, where in the CAN data set, you'll notice that around 24% have cerebral palsy versus about 2.5% that have it in the REN data sets. So now we reach our last slide. And I would like to point out at the bottom over there, I know this is a faux pas for a lot of people, but on the bottom, there's two different scales. The first scale is 0 to 15%. The other one is 0 to 100%. I'd just like you guys to keep that in mind, because when looking at grand mal, for example, it seems like HEAF1A has a huge percentage of people that have grand mal, but of course it's only 15%, versus if you look at many of the people in the REN database, that especially if you have Dravet, you have nearly 90% of people that have grand mal. And this is very useful information as it can be shared with others. And yeah. Okay, a quick summary. Basically, we're trying to see that looking at the power of the Aridia platform, we're seeing different ways to wrangle the data and how standardization of the data can be used for one, presenting, for two, to basically come up with new analysis and to realize things that we haven't really looked at before. It also allows you to combine two, or basically examine two different data sets or even more in the near future. And it will allow for generation of new insights. The platform is also developing new tools that will hopefully bring about greater advancements. Thank you. And I'd also like to introduce Ramona to the stage.
Thank you, Shlok and Alex and everyone who is here today for giving me this opportunity to talk to you about the upcoming technical developments in the RDCA-DAP. It's been so exciting today to be here at my first meeting among this community and really get a sense of the diversity of interests and passions that are out there in this group of people. And I'm sure, given our large online audience, it's even much more diverse than I'm realizing just being here in this room. So before I go into my slides, I first want to acknowledge this is very much a team and community effort. We could not do any of the work we're doing. I couldn't do my job without the incredible team that I have at C-Path, but also without the larger community of people working in rare disease ontologies and standards and data collection that are out there. And something that's really important to our team is that interaction back and forth with those teams, not just developing or taking their resources and using them. We really want to give back. And so we're always contributing to development of standards and ontologies as well. The second thing I want to say is a little bit of level setting, because there's some vocabulary in here. It is a technical talk. There's some vocabulary that many of the people in the audience may not be familiar with. The word ontology has been used several times today, and I'm over the top excited about hearing it said so many times, because that's really uncommon. And I live and breathe ontologies. So what is an ontology? An ontology is a specialized type of code that essentially takes human knowledge, complex human knowledge, things that we understand intuitively, and translate this into a format that can be understood by computers. And that format, the most widely used one, is called OWL, which stands for the Web Ontology Language. And yes, it is an acronym that is not spelled the same as the words that are in it. And that's a reference to Winnie the Pooh, by the way. The second vocabulary, so the second thing is with ontologies, you also have the power of reasoners. Because you've written this very structured language, you can use machine-based reasoners to make inferences, logical inferences over the data that are coded to that ontology. One more technology that I'm going to talk about, two more technologies, sorry. RDF, resource description format. It's simply a way, it's just a really simple basic data structure for communicating graph-based data. So if you've worked, many of you have probably worked with relational databases. It's one way to format your data and allow you to make connections across different data tables. A graph is a very different structure, and it's based on, as the name implies, nodes, a graph that consists of nodes and edges. So you have entity one, a relationship to entity two. And those three pieces make up something called a triple, which is the heart of what RDF is. Well, the graph database was the second one, so I kind of talked about those two ones. Okay, so with that said, let me dive into the presentation. And again, thanks, Shlok, for setting this up and talking about the value of how integrating and mapping data to a standard can really allow us to work across different data sets. Within C-Path, we are standards neutral. We have selected for RDCA-DAP several standards that we're using extensively, but the models and the work that we're doing are not necessarily tied to those two standards. But the ones that we are currently using the most right now are the OMOP, or Observational Medical Outcomes Partnership Common Data Model, the OMOP CDM. And we're using that. That grew out of the electronic health records world. It's very well suited for observational data and particularly designed to support analyses of data. And we have found that it actually works quite well for standardizing registry data, although of course there are some challenges there. One of the two big advantages with OMOP data, one is that it's actually a relational database model that does provide quite strong analysis capabilities. Another advantage is the use of the UMLS, or Unified Medical Language System, vocabularies like SNOMED, LOINC, and RX norm to standardize the terminology within OMOP. A second data model that we use extensively at C-Path and that we're adopting also in the RDCA-DAP is the CDISC Study Data Tabulation Model, or SDTM. That one is super important to us because it already is being used heavily for clinical trial data. So much of the legacy data that we're getting into the platform is already formatted into SDTM. SDTM was developed for regulatory submission. So it does not have the same finesse for reanalysis and reuse of data that OMOP has but it does have the advantage of being very accessible to people who have been working in a regulatory environment for a long time. It also has some standardized vocabularies for certain domains within it that are mapped to the National Cancer Institute thesaurus, or NCIT. And that standardization, it happens to be super convenient for us in working with ontologies because there is an NCIT OBO edition, OBO being the Open Biological and Biomedicals Foundry, OBO Foundry ontology effort. And so it's really quite straightforward to map from CDISC domains that use NCIT into ontologies. Standards are great. We fully support standards. I'm doing a whole breakout session on standards tomorrow, so I don't want to undersell them at all, but they have their limits. They can only take us so far. And so even within the very small example of the two data sets, the two rare epilepsy data sets that Shlok talked about in the last presentation, we've come up with some challenges already. And I want to be very clear at the beginning that these challenges are in no way a reflection of the quality of the data set or anything that those registries did wrong. It's simply a result of the nature of the fact that we don't have a standard way for registries to collect data at this point. And so people ask questions in different ways. And so then we have to try to figure out how to put them together. So one challenge that we come up, the first scenario is when defining the type of seizure. In the REN data set, when they want to define the seizure, they ask a question like, is infantile seizure present in this patient? And they have a time range or a date at which that seizure is present. So because we have a date and because we have a specific condition that can be standardized to OMOP, we can put it in the OMOP condition table. In contrast with the CAN data, the format is more like a medical history, and they ask a question like, has the patient ever had infantile seizures? Now that might seem like to you and me as humans, that's a pretty small difference, but to really try to understand what that means, there is a very subtle but important distinction, which is that it's not date coded. And so you can't, according to the OMOP rules, if you want to be compliant with the standard, you can't put it in the condition table. So we record that in the observation table instead. Again, fine for us as people, we know where to go find it. But if you're just coming in and you're new to the data set, how do you know that you have to, if you want to find all of the seizure data, you have to look in both the condition and the observation table. So how do we fix that? We can use an ontology to consistently encode all observation data, whether they're conditions or other observations, and make them discoverable in one way. So that's one thing we're doing. Another scenario is the way that data are recorded. This is a very common thing. A question will be asked, such as, are eye or visions problems diagnosed or suspected? Two challenges in there. One, eye problems and vision problems. Both of those are standard codes in OMOP, but they're two separate standard codes. And there's no parent concept that unites the two of them. That we can easily overcome with ontologies through the use of a hierarchy. We can build what's called a union class, and we can therefore use reasoners to infer that anyone who comes in with a query looking for vision problems will find the data about this. But there is a more complicated problem, which it says that, is it diagnosed or suspected? So again, we don't know, was it diagnosed or was it suspected? Again, we can't put it in the condition table because it doesn't have a specific diagnosis with a date, but we still want, as the researchers, we're going to want to know about that. If you're coming in trying to set up a trial, you want to know if one of the patients in this data set may have this eye or vision disorder. And so we need to make that discoverable. So the key here is that we need to get past the specific vocabularies and wording, the way that questions are worded, and get at the semantics, that is the true meanings of the data set. And that's what ontologies are essentially designed to do, to really get at the underlying meaning of language-oriented data. Okay, so I'm going to go into the next few slides that really are going to talk about some of the requirements and the benefits of using ontologies. And I would really like to stop and thank my colleague Nico Matanzoglu, who contributed not only this slide, but made great contributions to the coming slides. And it was Nico's idea to call this the Maslow pyramid of knowledge needs, right? So it's kind of a take up on the pyramid of psychological needs. Well, so what do we actually need to understand knowledge? So it's almost impossible for me to see my own slides. So bear with me. Starting at the very top, we need fair and open semantics. So probably most of you have heard of the FAIR data movement: findable, accessible, interoperable, and reusable. So that needs to apply to semantic technologies, not just to data itself. Going one step down, we need open and transparent curation. So one of the great things about working in the 2020s already is that we have tools like GitHub and GitLab. We can have conversations about what something means in an open forum where the history is recorded. And when you have a global community contributing to ontologies and to standards, this is so important and so essential because it allows for the evolution of knowledge and scientific understanding over time. Verifiable, correct representation of knowledge. What does that mean? That means we need ontologies. So ontologies allow us to not only build logical models, but using those tools called reasoners that I mentioned before to verify whether or not what we've built in our model and the data that we've mapped to it to verify whether or not that's correct. Then it's not enough to have one good ontology. We need a whole bunch of them, and they need to work together. And that's what things like UMLS is really good at. That's what the OBO Foundry was built on, the principle that you should have a suite of interconnected domain ontologies. And finally, once you've got all of those pieces, you can build this rich interconnected knowledge graph. And that's, you may have heard the term linked open data. That's what we're building here. In biomedical knowledge, this is an effort that's been going on by many people over the last 20 years to build essentially a web of knowledge around biomedical data. And we're coming in now in the last 3 years with RDCA-DAP on top of this incredible infrastructure and data that's already been built. How can we take advantage of that and make sure that we don't lose all of the knowledge that's already out there in the community, in addition to bringing in all the new knowledge that's the patient level knowledge that we're getting through RDCA-DAP and integrate those two pieces together. This is a series of points about verifiable knowledge content in ontologies, and I'm going to kind of gloss over it because basically what it says is you can use reasoners to detect mistakes in your data set. And I wanted to have it in the slide so that you guys can go back and look at this later if you're interested, but I'm not going to go through the details because it's less exciting. But you can find mistakes using ontologies and reasoners. That's the take-home message here. You can also ask more complicated questions, the bottom part. You can ask complicated questions like, find me diseases that are inflammatory diseases that take part in some part of the digestive system. Now, you can do that in a relational database model if you've built it right. But your model has to be built just so. The great thing about ontologies is they're super flexible. As you get more data and more knowledge, you just kind of add onto the graph, and you can do these much more complicated queries. So going on to one of the more complex pieces of that, the lower down in the pyramid was this need for rich interconnected ontologies. So as I mentioned, we are using OMOP to standardize across data sets. And if you look at the left side of this graph, you can see that OMOP is linked to things like ICD-10, LOINC, SNOMED, MESH. And right there, we are able to very richly capture observational, particularly real world data, electronic health record data. And we're using it again for registries. So why do we go further? Why do we bother to then do this additional laborious curation to ontologies like OBO Foundry ontologies? Well, because on the right side, you see the OBO and all of the things it's connected to. So OBO ontologies like Uberon and HPO and Ordo have been used for many years as the vocabularies for biological data annotation. So they are already connected to Orphanet, to the Alliance for Genomes Research, for Open Targets, for MedGen, et cetera, right? And so if we want to bring together this rich patient level data that's coming from real world data sources and the rich domain knowledge that's coming from the OBO ontologies, we need some to bring them together. We are experimenting with using UMLS, and my colleague Will has done some cool work with using UMLS to map within OMOP. We're also trying to use that as a bridge to map to OBO. And so building this knowledge graph that tries to bring it, I was really excited today when Dr. Dunn this morning said something about how do we bring together all the different data types. That's what we're trying to do here, is like bridge the genomic data, the imaging data, the patient level data from clinical trials, the registry data, and bring it all together, because of rare diseases, we need to know all of it. There's so little data that we need to bring in everything we can. Okay, so once we've brought it all together, we get a knowledge graph. And this is a really very tiny part of what our knowledge graph, which only contains 2 data sets. It doesn't even contain Ren and CAND yet. We're still working on adding those. This is containing data on Friedreich's ataxia and DTRF, the Desmoid Tumor Research Foundation. They're 2 data sets. So if you look at the left and upper side of this, we've got cross-species knowledge that's coming from the from like a taxonomy, essentially. That's based on the NCBI taxonomy. You've got disease ontologies. Those are the orphanet diseases, Mondo disease, the human disease ontology, those diseases. And then you've got all of these anatomical and morphological. It doesn't matter that you can't read what's on those. Don't try. I mean, you're welcome to. There's no secrets, but it's not really that important that you read them. But you can see. So this is everything that's on the left and the upper side is essentially knowledge that's already out there. So that little pink dot in diseases says Friedreich's ataxia. So you can go from Friedreich's ataxia and use graph going from node to using edges between nodes and find out what phenotypes and what morphological and anatomical features it's connected to, where there's research in other species that might inform your research in the cross-species knowledge, what the genes are that have already been associated with those phenotypes, in the proteins, et cetera. So there's this rich knowledge there. And then what RDCA-DAP adds that's so exciting to me is that little part in the blue circles in the left. That's the actual patient level data. Each blue dot represents an individual patient who has Friedreich's ataxia. And even though we stopped here, but it can go on and on. So we can talk about then, okay, this patient, which phenotypes do they have, et cetera, and go. And where we would love to go in the future is to start to build this out so that patients can really come in and start to explore the pathways within the graph and understand their disease better and understand how it connects to other diseases who might. So if your node here, the central node is disease, but imagine that your central node was a symptom or a phenotype. You could see which diseases have that phenotype, what genes drive those phenotypes, et cetera, and start to explore and learn things that way. Okay, now we've got the knowledge graph, and you can start to do even more cool things with it. So one of the key research techniques that's used with knowledge graphs and ontologies is something called semantic similarity analysis. This is from our data set, but it's a really simple comparison showing two anatomical features: the renal glomerulus and the glomerular capsule. In between is the ontological graph that shows all of the classes that are used to define those two features and how they relate to one another. And in semantic similarity analysis, you essentially do a path length analysis and you show how much of the pathways between those two diseases are shared. And that tells you how similar they are. Obviously, that's clearly dependent on the graph that you build. So that's going to really heavily influence your results, which is why it's so important, if you remember back to the top of the pyramid, to have that open community discussion to make sure that your knowledge is as accurate as it can be. So this is a pretty simple analysis showing that, not surprisingly, these two anatomical features are very similar. Semantically, they have a similarity of 0.95. We can use that kind of analysis. This is a future direction talk, right? So we can't do these things yet, but the kinds of things that we can do as we get more and more knowledge into the knowledge graph using analyses like semantic similarity would be doing things like discovering potential genetic mechanisms for phenotypically similar diseases. That's something people are already doing. So these kind of go from like, yes, we can do them now to someday maybe we'll be able to do them. So yes, we can do that. And that's so crucial with rare diseases, right? When you have so little natural history on a particular disease to be able to work across them. Within C-Path, working with Lindsay, we're starting to explore the potential for looking at clinical outcome, for using semantic similarity analysis with clinical outcome measures. So if you have an unstudied disease that doesn't have any clinical measures, can you look at phenotypically or genetically similar diseases and you see what measures have been used for them as clinical outcome assessments and start to compare them? And can you perhaps more objectively analyze clinical outcome composite or multifactorial clinical outcome assessments to see how similar they are and how well they might apply across different diseases? Getting way out there, you can imagine using similarity analysis to do things like repurposing of orphan drugs. So looking at how, based on the similarity of their genetic or phenotype or other physiological mechanisms, can we start to identify appropriate treatments or drugs for those diseases based on how similar they are to one another? So this is a future direction where we're moving ahead. To do all of this, we're building a critical path, the critical path ontology, which we call C-Pont. And C-Pont is an application ontology. It means it's not we're not creating a bunch of new terms for it. We're trying to reuse existing community resources, such as the Human Phenotype Ontology, the NCIT thesaurus, which I already mentioned, Phenotype and Trait, Anatomy Ontology, or Uberon, the Monarch Disease Ontology, the Order Disease Ontology. We are creating new terms where we need them, but we're really going to work hard to reach out to those ontology communities and get them to add new terms for us rather than developing our own terminology in a silo. C-Path is open source. It's available through that W3ID URL. We will be distributing the slides so you can get all these links. And you can contribute to it via GitLab if you would like. And the GitLab is there. Link is also open. Our current focus for the first round of curation has been on diseases, phenotypes, and laboratory measurements. But as I mentioned, we're beginning to explore using it for clinical outcome assessment measures. We'll be curating drug data as well, and we'll be looking at other areas, adding new diseases, et cetera. I don't need to show you this. This is just kind of a high-level concept map of the way that the C-Path is structured. So I leave it in there if people want to look at it later. And then I'll just take one last slide, which is talk about looking ahead even further, like what are we going to do? So we got this data, we're starting to standardize it. How do you get to it? So we're working very closely with Iridia, who is our partner in platform development. So Iridia Digital Research Environment, which they're going to see another talk on tomorrow. They're going to talk to you about these exciting new features that they're building, in part through support from the RDCA-DAP, including faceted search. So you can look along, find me any disease that has to do, find me a data on any particular phenotype or on any particular disease or any particular drug, et cetera, and using the hierarchical nature of ontologies to enhance that search. Again, that's also independent of the standard that's used. They're building a cohort builder for us, which allows you to do so. Shlok showed some of the data analyses that were capable in the platform right now. But the nice thing about the cohort builder is it essentially lets you do that before you request access to the data. So if you want to look at a data set and see how many patients have I got for this and which symptoms and how complete is the data, et cetera, the cohort builder is going to be incredibly valuable for that. And then finally, a bit further down the road, we have, as you saw some screenshots from it, we are looking at trying to stand up a browser for the C-Path ontology and the knowledge graph that we're building, so that patients and researchers and patients can essentially go through together and explore the, sorry, not together. They can both go through or together if they want. That would be okay. They can explore the knowledge graph. We're exploring with two different ways of presenting this. We want to make it as rich as possible, but there are always these access and permission issues. So like we can't necessarily show a patient level knowledge graph. So we're doing a lot of experimentation and work with synthetic data generation to make our data more accessible and to provide a knowledge graph that perhaps is based on synthetic data so that anyone can come in and see the data sets. And I think that's my last slide. Yep, thank you. And Alex.
Thank you, Ramona. And for the last presentation, yeah, sure.
People in the room who probably could not have even guessed at the definition of ontology, and I'm still not sure I can. But what I do understand from your wonderful presentation is that the wonderful work that you're doing is probably going to deliver on the promise of what we can learn from each other. So yeah, thank you.
That's the entire point of this. This has been what my career has been based on.
Yeah. So 3 words.
After we have one.
3 words. Wow. Thank you.
Thank you. And so for the last presentation, I wanted to end, back to the patient and the patient voice and our, what will be the future impacts through our collaboration with Nord. So I invite Pam to join us to present about the future impact for patients. And then after Pam's presentation, we'll have a Q&A with everybody on stage, including Penny Dacks from the AFTD.
Thank you, Alex. Just have to look up to make sure I remember what I was supposed to talk about. I got so enthralled in Ramona's presentation. I have to take a step back and say between that and our wonderful Ron Bartek's heart, it brought me back to this thought about how wild our lives can be in crossing one another's paths, and how I can't believe, having the opportunity to be a part of this day and work with an incredible team at C-Path and FDA and NORD. Similar to Charlene, my field of work before coming to NORD, before having rare diseases enter my life, was working in the healthcare IT space. And I thought it was super cool to be able to go into a hospital or a clinic, skilled nursing facility, or even a hospice, kind of like from cradle to grave, and go from paper-based charts to an electronic health record where you can go in an institution, there's not one piece of paper. And I thought that would be the end of it. We'd solve all the world's problems. And then entered in medical errors in my life. And that's how I converted to becoming an advocate and leveraging, the access to data, and then fast forward rare diseases, and watching my nephew being, who had MLD, metachromatic leukodystrophy, being cared for amazingly well, fortunately, by the home health nurses, and all his data being captured in a laptop, and people not really having the benefit of that life experience, because it was way too much effort to take him and his younger brother and sister in a van and drive him up to Boston Children's Hospital. And he lived a lot longer than he was supposed to live. And I can tell you, nobody really knows why, because the opportunity to learn from that life along with others was lost when that data was locked in the Visiting Nurse Association's system. So, fast forward to my opportunity to work at NORD and work for the community that so affected my life. And to be here today and to see Ramona talk about all the data elements and the data standards and the experience and all the other great people, I feel like it's come full circle. So the gift is really you all giving me to be here today. So that brings me to really what we're trying to do in the future as we build upon the first 3 years of success in the program working together. You heard this theme from the beginning of the day on through, that there's a lot of need for education and to meet people where they are and recognize that everybody's journey, just like mine coming to today, is different, but we all want and share the same thing, which is to improve the lives of people living with rare disease, to contribute to a better tomorrow, to leverage all the great medical brains and scientific brains in this country and the wonderful discoveries that are taking place. And so one little part that NORD is working on with the community in the future is to ensure that we provide the right education, because as we said, in the field of rare disease, patient advocacy organizations play a unique role. So as we take the educational programming that we've been working on and that Eliza and Ed talked about earlier today to the next level, we recognize that we need to level set and make sure that we have a really good foundation of deeper knowledge, an opportunity for deeper knowledge for the patient and patient advocacy organizations and the families, the community, to understand the drug development and the regulatory process. And for them to also have the tools that they need and can use should they wish to use them, because we know they don't all, to maximize their engagement, their time, their life experience, their commitments, and whatever financial resources they have, to help to do their part and effectively accelerating the drug development process. So with those aims, we are setting out to develop more educational programming that addresses various different formats of learning. My education team at NORD has taken me to school on the different ways adults versus children learn, and that we have to build multi-formatted approaches to people's learning tendencies or preferences. So we're going to do that. We want to make sure that we cover things such as the drug development process and the major tasks involved. What roles do stakeholders play? You'd be surprised how many patients and families think that FDA develops drugs. So how can we expect them to engage effectively at, come to the table with the right bits of information and capacity when they don't understand the process? What's the difference between a natural history study and a registry? When do you use one? What are the benefits and the limitations? Investigational treatments, how would we measure whether or not it works? What kinds of questions should patients and patient advocacy organizations and families ask when they are engaged in a discussion on the design of a trial, clinical trial? What are endpoints all about? You heard about those. Again, preaching to some very well experienced and educated people in this room. But we want to make sure that the entire patient community, to the extent that they're interested, is operating at the same level of knowledge. So then they can help participate in the process. And that means also looking at patient preference studies. We talked a lot about PROs and COAs, regulatory flexibility. In the field of rare disease, that is an awesome thing. But what does that mean? And how can they be engaged in that discussion to the benefit of that drug development process? And then last but not least, we're going to focus on labeling so they understand the ins and outs from the perspective that makes sense to them. What can they contribute to those discussions? We're also going to focus on some of the data and the data standards that Ramona talked about. We got more work to do this coming year on that from NORD's perspective, and we're looking forward to expanding upon not only the kinds of data that is contributed, but also to Dr. Dunn's point in the beginning of the day about the longevity and the evergreening of the program. That's also an important part of it. And there's just an example of one. We're going to focus on some projects that we can work on together where the opportunity is there. It's ripe for a project, and the time is right, similar to some of the discussions we had in the late morning and early afternoon today. So there's still a lot more work to do, but we've got a great foundation upon which we're building. And I will end here so that you can also hear from Penny as well.
So all the speakers, please come back. We're not going to do a panel discussion for 1 hour, don't worry. Just wanted to give you the opportunity to ask all our speakers specific questions. So I'll start just with a question with Penny. For Penny, you've seen a lot today. So I think just a very general question, from your patient community perspective, what really strike you today? Like, what do you feel is relevant to your community? Where do you see hope on things that we do at C-Path that will help? I guess maybe a global perspective on the day.
I don't think it was on. There we go. Thank you. I think this is an incredibly exciting time in general. And I think the resources highlighted today are just compelling to me and feeling that we're really on the cusp. I would say we're not fully there yet. And I say that because I look at, say, a very high profile neurology condition with a 99.96 failure rate. And I've seen 90% failure rates for clinical trials for all of neurology. And I would argue that if you go outside of symptomatic agents to truly disease modifying therapies, I think we do not know what we're doing, to be put very, very bluntly. And none of us like to hear that because it's certainly disheartening. But part of what I get so inspired hearing from RDCA-DAP and everything that's being created is that it's creating a resource to learn from every type of data that we can get our hands on. And I say that including the level of the clinical trials that are underway that have lessons learned for so many different folks. And it's about creating an infrastructure to me that can go beyond the lessons with one specific study, one specific question, and then it's gone. Because that 99.9% failure rate is real failures because we're not learning from those failures. And it's not feeding back to the preclinical understanding of the disease, and it's wasting participants' time. I have to admit, I do worry even seeing examples of, I mean, it's breathtaking, the progress, but you think about 5 to 10 years for creating a single tool that could be used in the pre-competitive space. That's slow when you think 7,000 rare diseases. This is hard. And I think it's one of the things that I love most about being in a field like this is that everybody from the FDA to the folks at C-Path, to the companies, to the folks at the companies, to the academic researchers, to the participants and the families that we serve, I think everybody truly cares. And that is inspiring, and it's incredible to think about the cusp of how this technology is going to translate. I think there's a lot of specific details and challenges we didn't get a chance to really cover.
Yeah, I think we have a lot to cover. Charlene is going to have to catch a flight very soon, so I engage. If anybody has a specific question for Charlene, please go ahead now. Otherwise, you can be excused.
From the interrogation.
Oh.
Can I just say that your last architecture slide went past quickly? I wondered if you cared to elaborate.
Yeah, thank you. It was really meant to talk about the process that we take from a data perspective, and obviously much more high level than the awesome presentation that Ramona went through. But a key aspect of our data collection is that we first of all are using data standards. We're using tools that exist, where possible for data collection. And then we're applying data standards so that when that data is collected, it can be used for downstream analysis and federation. And then a key other piece is that we are also aligning to other data sources. So, with partner data, what we want to do is, where it's possible to link the data in a useful way, we want to do that so that when the data is actually brought together, it can enable further insights. And then I guess the piece at the bottom was really just a very high level indication that our expectation is to really be able to bring that data, the Rarex data, into the RDCA-DAP environment and be able to then enable further analysis.
Thank you, Charlene. I think you're excused. The other Alex in the room has been dying to ask a question.
I'm sure we must. First of all, it's extremely impressive what we saw, all these presentations. And being a director of Bioinformatics Center, so I'm always challenged to explain to clinicians and patients what I do, how much effort, harmonization of data may take. So, but based on the Pam story, so that was involved in LD research, so so how do you harmonize concepts? So in your Maslow pyramid, right, so FAIR, and A in FAIR stands for accessibility. So if in Ron's data set it says for Friedreich's ataxia research only, then merging this data with some other disease, you're violating the consent and promises to his patients. So in our research for the past 6 or 7 years, we have data will be used for any medical research purposes. But how do we propagate this formula to all consents? Because otherwise it's impossible to do what we do without violating the promises to the patients. And IRBs are not happy, I can tell.
So I think that's actually a consent question more than a harmonization question. And that's something we've been working on very hard in RDCA-DAP, is to ensure that we have the proper permissions from all the data contributors to do the kind of work that I'm describing. And Alex, would you like to say more?
You're violating
Yeah.
Just-
Yeah.
Well, I mean, yeah, I think you answered. There is always a limitation, and you know, we have to respect each data set contributor. So as you know, it's one of the limitations that we have to play with. In terms of this effort, we want it to be as open to the external world as possible and sharing back. So some of this being able to use some of the tools that Ramona is developing might not be feasible for some data sets for external users. Keep in mind that, you know, one of the main goals of the program is to work internally to kind of start developing solutions within the program. Some of these solutions can remain internal, and we'll be able to use that technology and leverage that technology internally. So it's really important to like just remind yourself of that, and that the opportunity to collaborate with us on solutions development opens for more data. And when I showed the data set that we have, I insisted on saying there is more. Because there is more, but we cannot show everything.
I mean, the C-Path model of developing consortia and research projects that have, even when the contributors are not, no matter how persuasive Alex can be, if they're not willing to make the data available to the public, they're off. In the RDCA-DAP, they have to at least say that the data exist. That's a start. Yeah.
If organizations like NORD, if not C-Path, could be this, you know, power to promote and educate, to make sure that A, patients understand why we're asking for sharing, and B, you know, probably shame clinicians, institutions, organizations that are not willing to share for whatever reasons they are.
I would agree.
Do you want to react to that, Penny?
Yeah, if I can. I think it's an incredible resource for groups like NORD, maybe, to tackle of like a template-informed consent and as well as education around it. I also think that we need to remember who are the communities that we've not brought into this conversation. There are communities who do not have the same level of trust with researchers, and there are reasons for that. And as we seek to be more inclusive, we often forget that there are components there that we need to truly not just say, oh, well, our intentions are really good, but actually stand behind that with clear thought. And the other piece of this is international regulations, which for, I think, every single rare disease is going to face international trials. And we haven't really discussed the pragmatics of that in a deep way today.
Thanks, Penny. Mr. Barry?
Do I have to introduce myself, Alex?
Or is Mr.
Anyway, Ramona, I think you can hear me. I was wondering, do you think it's possible to reverse engineer some of the semantic similarities approaches to address redundancy of operational data as well as data quality?
Not sure I completely understand what you want to do there.
Okay, so in the pharmaceutical industry, they're purchasing a lot of data, and certainly we're consumers of different data sources. And obviously, you know, as you're assessing information value, you want to prioritize, you know, those data that offer the best benefit, particularly for certain context of use solutions that we'd like to develop in collaboration with the ecosystem.
Yeah, so that's definitely an act. I think it is possible. It is someday. I think it's a very active area of research right now. So, for example, to take two data sets that have been de-identified and try to determine if you've got the same patient in both of them, right? And I think the ontologies and the standards can play a really crucial role in that. I mean, we could avoid that problem by just having globally unique patient identifiers, and one place where you could go to find the ID and validate patients, but that's not going to happen in the near future. So yes, it is. I think that, you know, one aspect that I didn't even talk about was the real data sciencey parts of the work that we're doing, and that the community in general is doing, to use various AI methods to not only speed up. We internally, our focus within the data science team is to use AI methods like machine learning and natural language processing to speed up the curation and mapping process. But there are also many other methods out there that are being developed, like you said, to try to remove redundancies and maximize the information content within a data set that you can get, for sure.
All right, I don't see any further questions. Oh, you have one? Oh. Please do.
I wasn't sure if there was time. Ramona, the opposite of his question. When you had the slide up there that said public forum resolution, how do you figure out who's the right one? It's not always 10 people said the same thing and they must be right. So how do you figure out, if you've got conflicting information, which one is the right answer?
Well, I would say that 70% of the time through extensive discussion, and often like a GitHub issue tracker, if it's a particularly difficult issue, the flow of GitHub is not sufficient. You have to sit down and have a call with each other to hash it out. And at least 70% of the time, a consensus can be reached. And when it can't, then you have alternate data systems that have that. There are ways within ontologies to allow for different viewpoints, to encode the knowledge differently, and to be explicit about, we're treating it this way, that group is treating it this way, and you can both. We do this a lot with data, like, so you have a disease, a symptom that's classified as mild, moderate, and severe, and so and if it's something that's actually quantifiable, some people consider 0 to 10 mild, some people consider 0 to 25 mild. It's fairly straightforward within an ontology-based data system to allow that classification aspect to be customized on the application basis and allow different people to come. As long as you don't lose the original values, different people can choose to classify them differently, and you can do that fairly quickly with an ontology.
Yes, and Penny's point is a ridiculously important one. So to that point, if you get voices together and everyone agrees, but you didn't have everybody in there, that's an important one, because that 0 to 20 could be based on people who aren't included. So I want that to be part of what you're thinking about as well.
Yeah, and I think that's another reason why it's so important to have the public forum and see who has been included, so you can also go back and figure out who hasn't been included. Yeah. It's all about open science, right?
Well, I get the sign that we need to wrap up. Maybe Penny, any famous last word? We don't have to.
I'm grateful to everybody in this room for the incredible work that's being done. And I hope that 10 years from now, there will be some profound changes in from the technology and the ontologies and how easy it is to do the right thing, as well as the cultural changes about let's get to the place where science can be and companies can be competing on their actual drugs instead of on how to actually execute on a trial.
I approve this message. Thank you.